Hello and welcome to Honors Function. This is the first of a 3 series on the algebra of function. What does algebra of function means? It means I'm going to combine function and I'm gonna study the property of this combination. How are we to combine function? Let's begin. In order to combine function, I need at least 2 functions, so I'm gonna take f and g. How am I going to combine them? The first thing I will look at is this function called the function sum. Then I will look at the function difference. Then I will look at the function product right here. Okay, how do we define the function sum? So I'm about to construct a third function given 2 functions here. Therefore, I have to tell you what happens to an input. I'm going to give you its rule of assignment. What's the rule of assignment of the function sum? It's very simple. It's a sum of the output. What's the rule of assignment of the function difference? Again, very simple. It's a difference of the output. And finally, for the product, we do just the same thing. We take the product of the output. Okay? Right here. Okay, now just a precision here, a technical detail. These operations on the right are operations with which you are very familiar because this is a real number and this is a real number. Therefore, these operations are just the combination of 2 real numbers. For example, 2 plus 3 equals 5. The operation on the left, this one, and this one, and this one, until now have not been defined. I'm still using the same symbol as this, but really, theoretically, it's not exactly the same because this is not a real number, right? So I'm adding 2 things that are not real number, but I'm still using the same symbol. Just, you understand why. I mean, look how it's defined. It's defined with the sum of 2 real numbers. Now, these are definitions, so I should put maybe a column before my equality to specify that actually it is a definition. What's on the left until I go to the right is not defined. I have no idea what that means until I go to the right, okay? Anyway, these are just technical detail. We also define 2 other operations, or 3 other operations, I should say. This time I'm going to define an operation between a real number and a function. F is a function this time, okay? This is called a scalar product. I'm going to define an operation between a real number and a function. And this operation, again, will have the same notation than the one I'm familiar with. It's a dot, meaning multiplication. It's called a scalar multiplication. Here, I'll write it here. This is a scalar multiplication, while this is a function multiplication, right? You multiply 2 functions, so they are not the same operation here. Scalar multiplication, how do we define this? Well, if you apply to an input, by definition, it gives you k times f of x, and again, here we have a real number, and here we have another real number, okay? So this, I understand this multiplication right here. Okay, I said 2 other operations. The other one is the reciprocal function. How do I define the reciprocal function? Well, straightforwardly, if I apply that to an input, I will find 1 over f of x. And now that my reciprocal function is defined and the product function is defined, I could define f over g. And by definition, for this one, I don't need to tell you what happens to an input because I can just say it's f times 1 over g. I just defined this one, and I just defined this one. Therefore, this is now well defined, okay? All right, let's go over an example. Here we go. In my first example, I'm given 2 functions, and I want to find 3g minus f times 2g, and f over g. So let's start with 3g minus f applied to x. Well, this is just 3g applied to x minus f applied to x, and 3g applied to x is just 3 times g of x minus f of x, okay? So what is this? This is 3x minus 3 minus 2 2x squared plus x plus 1. So it is negative 2x squared plus 4x minus 2. That's it. Done with the first one. Second one, f times 2g. So f times 2g. This is a product of two functions, right? It's a function f of x. It's a function f multiplied by the function 2g. Alright, but now 2g, this is a scalar multiplication of a function and a real number. So this is just f of x times 2 times g of x. Okay, so you multiply f of x and g of x and you multiply this by 2. I'm going to try to do it directly. Please make sure I don't make any mistake. 2x cubed, 4x cubed. Let me get my x's now. So I have x squared, negative x squared right here, and I have negative 2x squared. That would be negative 3x squared, so minus 6x squared right here. Now let me grab my x's. I have minus 1, minus 1, minus 2, so minus 4x. And finally my constant is negative 1 times negative 1 plus 1, so it's plus 2. Here we go. That's the second one. And finally the ratio, f over g at x. This is just f of x divided by g of x. So it is 2x squared minus x minus 1 divided by x minus 1. So we could try to go further here. We're going to have to be very careful though. 2x x minus 1 plus 1 over x minus 1. Yep, we're going to have to be very careful though, right? This is a rule of assignment of f over g. But we have to be careful. F over g is not just 2x plus 1, right? Because remember, a function is 3 objects. Do not forget this ever, okay? You got a rule of assignment, You also have its domain and its codomain, right? So you're gonna have to be careful here. 3 objects. Here we have the rule of assignment. As for the domain and codomain, well, this is a very good segue to the next problem, which is a domain, finding the domain of these combination of functions. So let's go to the second point now, the domain of the combination of these functions. So I'm going to start with the function sum, f plus g. Now remember, if you apply it to x, it gives you f of x plus g of x. I want to figure out the domain of this f plus g. What is the domain of a sum? Alright, so for that I need to understand what happens to an input, right? So what happens to the input? Well, the first thing that you do is you throw it into f of x, f, and then you throw it into g. Well, to be able to do that, you have to be in the domain of f, and you have to be in the domain of g, right? If not, these would be undefined. And then what? And then you add these two output. So then you do f of x plus g of x. Now, doing the sum of two real number, are you introducing any new restriction? Do you know of any two real number for which the sum is not defined? No, you can always add any two real number. Therefore, there's no new restriction. Therefore, the domain of f plus g is, you got to make sure you are in the domain of f, and that's intersection, you got to make sure you are in the domain of g, right? Okay, well guys, if you think a little bit, the domain of a difference, do you have any restriction for the difference? If you do the difference, do you have any restriction? Are there any two real numbers for which you cannot take the difference? No. Therefore, it's also going to be the domain of f minus g. How about the product? If you look at the product now, okay? So if you look at the product, do you have any restriction of a product? Are there any two real numbers that you can't multiply together? No. So it's also going to be the domain of f times g, okay? All right, now let's look at another operation we talked about, which is the reciprocal. So reciprocal operation is just 1 over f of x. So what happens to an input, well, the first thing that you do is you put it into f of x, right? I'm looking at this piece right here. So for that, I just got to make sure x is in the domain of f. And then what do? And then I take the reciprocal of it. Now, any restriction on the reciprocal, can you always take the reciprocal of a real number? Almost, right? Almost. You cannot take the reciprocal of a number that is 0, okay? So you're gonna have to be careful. F of x here cannot be 0. Yes, in this case, the second operation adds a restriction. And so the domain of 1 over f, what is it? Well, you got to be in the domain of f, right? To take f of x, you got to be in the domain of f. So you are in the domain of f. But here, you want to remove all the x's that will make f of x equal to 0, or else you will not be able to take the reciprocal of f of x, right? Okay, so that's going to allow us very quickly to look at the domain of f divided by g. So if you look at the function f over g applied to x is f of x divided by g of x, right? So what's going on to an x? Well, the first thing that you do is you put it inside f and you put it inside g. So you have to be in the domain of f, and at the same time you have to be in the domain of g, or else you cannot do this operation. Then what happens to f? Nothing here. Okay, so no restriction if you don't do anything. What happens to g? You take the reciprocal of it. So here you have a restriction. You just want to make sure g of x is not 0. And then what happens to these two quantities? You just multiply them together. Why do you multiply them together? Well, because that's going to give you f of x over g of x, right? I mean, that's easy. Any restriction to this product right here? No, you can always multiply two real number, okay? We've already taken care of this restriction because of the denominator here, all right? So, what is the domain of f over g? The domain of f over g is the domain of f and the domain of g, except all the x's that will make g of x equal to 0, all right? Okay. Let's go over one example. Here we go, example 3. Find the expression, that means a rule of assignment, and the domain of f over g. And I'm also asking you, what does the graph of f over g look like? Okay, so f over g applied to x is f of x over g of x. This is definition. So it is 10x squared minus 13x minus 3 over 2x minus 3. All right, let's try to simplify this if we can. So let me try to factor a 2x here, and here 5x. So 5x, 2x minus 3, 5x plus 1, right? Minus 15 plus 2 is minus 13 over 2x minus 3. So here we simplify, and we have 5x plus 1. This is just the rule of assignment, right? Okay. So now, what's the domain of f over g? Well, it's a domain of f, according to the formula, and the domain of g, right? Or else you cannot define one of the two operations here. And then minus, now to define this one, minus all the x's that will make g of x equal to 0. So, what's the domain of f? Do you have a ratio? Do you have a root? Do you have a log? No, no, and no. So, it's all real numbers. Same thing for the domain of g. And minus, so all the x's such that g of x is equal to 0, so 2x minus 3 is equal to 0. Right here. So, what is that? That r intersection with r is just r, minus 2x minus 3 equals 0, that means x equals 3/2. That's it, okay? So it's all real number except one value. And you see, if you only look at the rule of assignment, you wouldn't understand why you need to remove 3/2, okay? That doesn't make sense. This is defined at 3/2, but not f over g. What does a graph look like? Well, let's see. what does the graph look like? Well, let me first look at 5x plus 1 right here. Okay, so let me suppose this is it. Oof, that's going to be a really steep one. Actually, let me not put, because I don't want to make it too steep. Here we go. 5x plus 1. Let's assume this is 5x plus 1 right here, okay? This is y equals 5x plus 1. Now, this is not the graph of f over g, right? Because f over g is not defined at 3/2. It's not defined at 3/2. So right here, I'm going to have some issue with the graph of f over g. But apart from here, apart from 3/2, it's just 5x plus 1. So f over g is 5x plus 1 when x is smaller than 3/2. It's 5x plus 1 when x is above 3/2. And at 3/2, it's not defined. It has a hole. Now, this is a graph of f over g of x. All right? It's about the same as this one, except that it has a hole in it. Okay? Okay, let's go over one more example. Now, this is a tabular way to present a function with a table. It's a numerical approach to function. So let's go over 2 or 3 examples. I'll let you do the other ones. What is f plus g at 1? Well, by definition, this is f of 1 plus g of 1. What is f of 1? F of 1 is 3, and g of 1 is negative 3. So it's 3 minus 3, so it is 0. That's it. Very simple, right? What is, here, let's do this one. F over g at 1, by definition, it's f of 1 divided by g of 1. And we just grab the two value right here. 3 over negative 3, so it is negative 1. Okay? I'm going to let you do the other, for example, right here. They are very, very straightforward. The last thing I want to do is look at combination of functions with a calculator. So I'm going to show you how your calculator can easily graph f and g right here, the sum of f and g right here. But before we do that, let's look at the expression of f and g. I don't need to do that. I just want to look at one thing here. F plus g of x is square root of x plus 3 plus square root of 5 minus x, right? And that's it, and I cannot simplify that. So what's the domain of f plus g? Well, it's a domain of f intersection with the domain of g. So what's the domain of f? So f, x plus 3 has to be above 0. So x has to be above negative 3. So it is negative 3 infinity intersection with, what's the domain of g? 5 minus x has to be above 0. So x has to be smaller than or equal to 5 intersection with negative infinity 5, right? So it is negative 3, negative 5. The domain of f plus g is not defined outside negative 3 and 5, okay? You'll see that. You can easily see that with the calculator. So let's take the calculator. I think I've already entered my two functions. Yes, I've entered f into y1 and g into y2 right here. Now, let's... I don't want to graph, so look what I'm going to do. I'm going to go on top of my equality and I'm going to push enter. And this will de-highlight, or I don't know how we say, unhighlight the equality. I'm going to do that too. Because I don't really want to graph f and g, I want to graph f plus g. So what do I do right here? I'm going to vars, y vars, function, y1. Look, y1 plus, I'm going to do the same thing. Vars, y vars, function, y2, y1 plus y2, okay? And this is going to give me y1 plus y, the graph of y1 plus y2. We said we didn't want anything below negative 3, so I'm going to take negative 4 for my x min. I'm going to take 4 for my x max. No, sorry, it's above 5, so I'm going to take 6. Then y min, this is a sum of 2 y min, so this function is a sum of two radical square root, therefore it's non-negative, so I'm going to take negative 1 right here. Y max, well, I don't know how large it's going to be, so I don't know, let me see. Here is the function sum right here, y1 plus y2. It's not a very satisfying graph, okay? Let me remove some of my y max right here. Obviously, I don't need that many y max. So I'm going to go to maybe 5. Let's see what we have here. Right. So this is not a very exciting graph, all right? Let me graph y1, so enter, and let me also graph y2 right here. And let's look at the three graphs. So here's y1, here's y2, and here is the sum. Now, guys, I cannot write on this screen right here, but if you take this input right here, look, you're adding this value right here, whatever length of that segment is, to that length right here, and that's going to give you the whole length. Let me show you on the set of notes. So look, guys, I have my three graphs right here. This is G, this is F, and this is F plus G. Okay. All right. Now look, if I take an input like, let's take 3. Now look, the length of this segment right here represents G of 3. The length of this segment right here represents F of 3. If you take the green segment and you put it on top of the blue segment, you're going to have F plus G at 3 right here. So you can add functions graphically, right? You can add functions graphically. Let's look at one more point to understand that better. Let's look at the intersection right here. It looks like it's at 1. This is F of 1 right here, and this is also the same as G of 1. The intersection seems to be the same. So G of 1 right here. What is F plus G? Well, I'm going to take the blue segment and I'm going to put it on top of the green right here. And this should give me F plus G. Okay? All right. I'll stop this video right here. Thank you for watching.